Hello everyone, this is Siddharth from QA Infotech, anchoring today's webinar and supporting the event logistically. On behalf of QA Infotech, I would like to thank and welcome you all to this web event on Profile Year Applications to Measure End User Experience, an open source test automation solution. Not very long ago, the websites used to be high on static content with focus on the application itself. However, with changing times, the web applications are now being designed to be highly interactive, intended to work on personal computers, tablets, and smartphones alike, and focused towards the customers. The agenda for today's webinar is to discuss the current dynamics of rich internet applications, the implications of usability across various platforms, and our proposed solutions to help users achieve the ultimate web experience. Our speakers for today are Kunal Chauhan, the CTO of QA Infotech, and Ramandeep Singh, the head of our test automation group.
We will start off with Kunal, who will be providing an overview of the gap analysis and overall business implications, followed by Ramandeep, who will be delving further into the practical implementation of these solutions at QA Infotech with the help of some live examples. Please feel free to send your questions to us anytime during the web event using the Questions tab on GoToWebinar platform. At the end of the session, we will try to answer as many questions as time permits. All participants are on mute at this time to allow for the speakers to present. Over to Kunal now.
Thanks, Siddharth. So the rich internet application product release cycle involves development of the product, testing, and releasing it to the market. Generally, the testing involves functional, performance, and user acceptance. But many a times it is observed that within a couple of weeks of client onboarding, there are reports of random application slowness and it not being responsive as per the SLAs. Increased client disapproval leads to the product acceptance showing negative trend. So what happened when the application was properly tested? Where did things go wrong? Well, in such cases, the answer lies in end-user experience profiling. What is end-user experience profiling? How do we perform it? What approach needs to be followed? What points need to be kept in mind during the design, development, and profiling of end-user experience? Well, in this context, end-user experience is the time taken for the application to respond to the user so that the user can perform the next action. A snappy application leads to the satisfied user, whereas an application where page or content loads slowly results in the user being less focused and restless. So how is application responsiveness measured across form factors, hardware conditions, and browsers? To discuss this in detail and to describe the approach we follow at QA Infotech, let me give it over to Ramandeep, our head of test automation.
Thank you, Kunal. Before we dive into the webinar, let us have a look at the agenda. Firstly, we would talk about the conventional performance tests, and we would try to contrast them with realistic user experience. We would do this to understand the need of in-browser user experience profiling. Then we would look at a demo of one of our test automation solutions using which we are able to do in-browser user experience profiling. Then we would try to understand why all of a sudden now in-browser user experience profiling has become more relevant. Followed by that, we would look at the factors that affect user experience overall. And finally, we would look at the solutions with which we can implement effective user experience profiling and UI benchmarking in our test automation and testing projects. Let us try to understand the need of in-browser user experience profiling. When a user tries to access an application, he would use a web browser. and internally, web browser would fire multiple sets of HTTP requests to the web application server. The application server would respond in the same HTTP transaction. It is the responsibility of the web browser to render and provide a user interface to the end user, which the user can then use. The end user would then interact with this user interface or the web page, and the browser would record all these user interactions and would fire subsequent HTTP requests and wait for responses. In a load test, using any of the existing commercial and open source load test tools, the tool acts as a simulation of web browser. The tool would record all the HTTP requests that take place between the browser and the web application server when we are recording the load test. And when we run the load test, the tool acts as a simulation of web browser, and it would play back all the HTTP transactions. And while doing that, the tool would capture the response times of the web application server and the application for these HTTP transactions. The profile of the performance of the application is entirely based on the analysis of these response times. But if we look at the real end user's perspective, for an end user coming in from a browser, the overall experience and the overall performance of the application is more than just the response times of the HTTP transactions. The overall performance of the application also depends on the render time the browser takes to display the web page properly to the end user. So how do we make sure that when we are doing a load test and performance analysis of an application, we also incorporate the time it takes for the browser to render the web page properly to the end user? Well, the answer is to do in-browser user experience profiling. But how can we actually perform in-browser user experience profiling? Let us look at a demo. This is a demo of one of our test automation frameworks. This framework was originally designed to do functional test automation, but we have enhanced it so that we can perform user experience profiling with the same framework and test scripts. Once I execute the demo, you would see that the framework would launch a browser. It would launch Yahoo Finance page inside the browser, and the framework would capture the time the browser takes to completely display the page. Once that is done, the test scripts would go on to the next set of activities, which is performing a search inside the Yahoo page for a symbol and then recording the time it takes for the browser to completely display the results of the symbol. Let me run the test. I have executed the test, and you see that a browser has come up. This is Google Chrome, and it is pointing to finance.yahoo.com. The test scripts are now recording the time it takes for the page to completely load inside the browser, and once that is done, the test scripts would move on to the second activity, which is performing a search and recording the time for the response of display of the results for the search. This whole two set of activities would be performed for 5 to 10 different iterations, and at the end, results would be displayed. While these iterations are being performed inside the browser, an extension of the framework is also capturing the HTTP transactions that are taking place between the browser and the Yahoo server. The report at the end that we get would be a collection of the response times of these headless HTTP requests and transactions, as well as the overall response time that we get inside the browser, and then we would be able to compare the results. This is a long test, and while it is executing, let me straight away take you to one of the reports that we got when we earlier executed this test. You can see that there are two columns in this test report. The first column is for first browser and machine, which is Google Chrome, and the second column is for Firefox. The first graph on the top is a graph for the response time of home page load of Yahoo Finance. You can see that the x-axis is the number of iterations for which the test was executed, and the y-axis is the time in seconds that took for the responses. The blue dots in the graph is the time it took for the headless HTTP requests to complete, and the red dot and lines is the time it took for the complete page to be displayed properly inside the browser. You can see that there's some amount of difference in the HTTP response and the time it took to display the response inside the browser. The graph right below it displays that difference. You can see that in Google Chrome, the difference is close to half of a second, whereas in case of Firefox, for the same set of activity, the same test, the difference is about 2 seconds. It averages to about 2 seconds. We can clearly conclude from this report that Yahoo Finance page takes more time to render properly in Firefox compared to the time it takes in Google Chrome. The same conclusion can be drawn from the second set of activity which we performed using our test, which was to perform a search and record the time it takes to render and display the results of the search properly. When we executed these tests, what we also did was we executed the test on a third machine. And this time, the third machine had Firefox as the browser, but just with 1 GB of RAM. Now, compared to the machine with 4 GB of RAM and Firefox, the results that we got were really conclusive in the sense that in case of Firefox with 4 GB of RAM, the average response time was close to 2 seconds, whereas when the RAM was less to about 1 GB, the response time was more, in the range of about 2.2 seconds for each of the page loads. With this test report and the framework demo, we can conclude that the overall response time and performance of the application depends on 2 different factors. One, the HTTP response time, and secondly, the time the browser takes to execute the in-browser code and render the information properly for the end user. The overall application response time and profile is a relay between the HTTP transactions response time and the browser render time. Now let us try and understand why all of a sudden in-browser user experience profiling is more relevant now. There are a bunch of activities that are done either at the application server side or at the client side to render and display the web applications properly. These activities are handling and managing the data and data logic, generating the templates, generating HTML based on those templates and the data and model, having the behavior logic executed, and finally handling user interactions. There was a technology which was available back a decade ago using which most of the web applications were developed. This technology was Web 1.0. And we can see from this graphic that most of these activities that are executed to render the application properly, a major part of these activities were part of the application server-side code, and they were executed on application server. Whereas only the last 2 activities, which is rendering the HTML code properly and handling the user interactions, these fall into the client-side code of the application. The client here is the web browser. So we can clearly see that when we were developing applications in Web 1.0, the amount of time that the browser used to take to render the application was negligible compared to the overall application response time, because the activities that the browser was supposed to do were very minimal. When Web 2.0 and Ajax came into picture, these activities that earlier were majorly part of the server-side code of the application now became part of the client-side code of the application. For instance, handling the models, the template, generation of HTML, executing and generating the behavior logics and JavaScripts, and handling the user interaction. All of these, which were earlier part of server-side code in Web 1.0, now became the part of client-side code, which the browsers now have to execute. So what happened was the responsibilities of browser has grown. The amount of activities that the browser has to perform to render the application properly to the end user, those activities have grown. And with the emergence of HTML5, the thin line between the activities that server has to do and client has to do, that thin line has vanished. All these activities can now be done inside client-side code if you're building application using HTML5. So what is happening is, nowadays we are building very rich user experience-based web applications where the browsers have to do a lot in order to render these applications properly to the end user. So compared to applications which were built in Web 1.0, where the render time was negligible, the render time in present-day application must be considered when we are assuming the overall performance of the application. Let us look at this very interesting statistic. This is a chart of the global internet device sales. It's a chart of the sales of personal computers and smartphones and tablets. From this chart, we can see that in 2011, the overall sale of smartphones and tablets exceeded the sale of personal computers. From this chart and the trend, we can also predict that in couple more years, the overall sale of smartphones and tablets collectively would be 4 times more compared to the overall sale of personal computers. How does this affect the user experience? Well, when we talk about smartphones and tablets, however mobile and agile these devices be, they lack in the amount of processing power and RAM compared to personal computers. That means that a browser running on a personal computer would have more amount of resources to execute its instructions and activities compared to a browser running on smartphones and tablets. Because in smartphones and tablets, in order to make sure they are mobile, the designers have compromised in the amount of processing power and RAM that these devices can have. Let me show you one of a result from a similar test that we executed. This time, we are comparing the test results from on a desktop browser versus a smartphone. We use the same test framework that we demonstrated earlier, and this time the subject was mobile version of wikipedia.org site. We did the same test timing 2 of the activities of this website, one loading the home page and secondly navigating to the login form of Wikipedia. We executed about 50 iterations of this test on 2 different browsers, one on Google Chrome running on a Windows desktop, a personal computer, and another on the browser of Samsung Galaxy S2, which is a very popular smartphone. The red dots in the first graph is the time it takes for Google Chrome on a personal computer to complete its activity and render the home page, and the blue dots is the time it took for the browser inside Samsung Galaxy S2 to render the page properly. We can clearly see that in all of these cases, the overall difference between the time it took from Google Chrome on desktop to Samsung Galaxy S2 is about 1 second. That means in rendering and displaying the Wikipedia homepage properly, Samsung Galaxy browser takes 1 second more compared to Google Chrome. And the same result can be seen for the second set of activity we perform, where we are clicking on the login button and trying to open the login form of Wikipedia. 2013 has been termed as the year of responsive web design. What does that mean? Well, a couple of years ago, when web developers were designing the front end of the application, they were designing two different versions of the application. One for the bigger form factors for laptops and desktop machines, and one version of the application front end for the smaller form factors for devices like mobile phones, smartphones, and tablets. Because of this, the developers had the privilege of deciding what features can be trimmed down from the smaller version of the application, the mobile version of the application, so that the application can be rendered more faster inside these low performing devices like smartphones and tablets. But in 2013, the developers are focusing on making sure that they build a single version of the application front end. A single front end which is responsive enough so that it automatically adapts to any form factor of the device from which the application is accessed, whether it's a bigger form factor of a desktop or a smaller screen size of a smartphone or tablet. But the problem here is that the developers now do not have the advantage, although they may have the advantage that they are able to trim down the cost, the overall development cost of building the versions of application front end, but now because they need to maintain a consistent experience across all form factors, they cannot trim down the application features from the front end. That means the application user experience must be consistent across all different form factors in terms of the features that it has or in terms of the performance of the application front end overall. Now let us try to see what are the factors that affect user experience. When we talk about web applications, the web application HTTP performance is definitely the biggest factor of slowness or overall performance of the application. But besides that, there are a bunch of other factors that affect applications HTTP performance. The network performance and bandwidth using which user is trying to access the application. For example, a user who is trying to access the application from a browser inside a desktop machine would be on a broadband connection and would definitely have higher bandwidth to render the application faster compared to a user who is coming in from a mobile device. The user from a mobile device would be on a 3G or a 4G network, so he would definitely have a limitation in the amount of bandwidth that he has to display to open the application properly. And also on top of that, the mobile user would be on roaming and relocating from places to places a lot of time. And because of that, the reliability of his network would be far less than a dedicated stationary broadband line. If there are too many asynchronous calls inside the applications, assume an application page which the user has opened up and he's trying to perform an activity in the application. But the application is firing at the back end a number of AJAX calls to predictively and smartly load resources for the next set of pages that the user might end up once he performs a set of activities. A number of these loading might be unnecessary because user might not end up on these pages. But because these asynchronous calls are being made at the background, the overall performance would be affected by these calls. How are the static files in the application handled? Does the front end have a proper way to channel and display the static files, deliver them through a proper static content delivery network? Is the browser allowed to properly cache the static files at the first time the application and static files are loaded? All these points affect a lot the overall experience, the overall HTTP performance of the application. Users access configuration. The configuration that the user is using to access the application also plays very important, is one of the very important reasons for slowness in the application user experience. A user coming in from a desktop machine running Google Chrome would get better user experience performance compared to a user coming in from a mobile device because of the availability of execution resources for the browser. Similarly, if we compare the responses of application rendering on Google Chrome versus Firefox and Internet Explorer version 7, we would see that Google Chrome is much faster. We also demonstrated that from one of the reports that we saw. Finally, and the most important thing besides the first two factors is the application's client-side code and the performance of execution of this code inside the browser. That is one of the reasons for the slowness of the application at the front end. There's a lot of JavaScript code and huge amount of data that the browser has to handle before it presents the application pages to the end user. On top of that, the browser also handles a bunch of browser plugins and code that these plugins have to execute to properly display good and rich application UI. These plugins are like Flash, Flex, and Silverlight. Collectively, the execution and performance of all these code makes it really difficult to judge the overall performance of the application. I can quote an example here. Very recently, we were testing an application which is used by field users to enter large orders. In order to enter these orders, the users were supposed to fill in forms, and some of the fields inside the forms required them to fill in, to pre-populate the inputs of the fields from a pop-up window. When we did a load test of the application, we found out that the AJAX calls for the calls that were made to get the data of the pop-up windows was well within the benchmark range, an acceptable range of response time, but the browser was taking a lot of time to actually render all the data in the pop-up. What was actually happening was that the application was built on ASP.NET and the application front end was using a lot of JavaScript and data grid to render the information properly. And because of the huge amount of data it has to render, the browser was taking a lot of time for rendering that. So in this case, the reason of performance slowness was not the HTTP response, but the front end code of the application. So how do we implement a solution that we can use to properly perform and effectively perform in-user experience profiling? We need to perform a bunch of steps. They are, first, we need to identify the user experience workflows, the activities which we want to profile and time. Then we need to determine the HTTP calls, synchronous and asynchronous calls, that take place when an activity is performed inside the browser. Then we need to automate these activities in the browser using available test automation options. In our demo, we used an open source, a framework which was built using Selenium, which is an open source technology. Then, once we have done the first three steps, the next step would be to apply timers in order to capture the time it takes for these activities to be completed inside the browser. And finally, we need a way to intercept the HTTP calls that take place when these activities are performed inside the browser. Once we have a solution in place to take care of all these steps, there are two approaches in which we can incorporate in-user user experience profiling in our standard test automation execution. One is to execute the test build by build and compare the results across. For instance, assume an application in which on the first build of the application, 2 features were added on page A of the application. We create a UI profiling test for this application, and when we execute the test, we record the results. In a new build of this application, either the existing features were refactored to optimize the performance, or newer features were added to the same page. When we execute the test again and compare the results of the current build with previous build, we would be able to determine whether the refactoring activity has enhanced or degraded the performance of the front-end code and the overall user experience. And also, we can determine whether the amount of features that were added in page A, whether that has made the page to render properly, faster, or whether the overall performance of that page has degraded. Similarly, we can use the same concept and same kind of execution to profile and check the overall user experience of the application under different devices and configurations. We can mark one of the configuration as a benchmark for our application, record the results of the test, and then compare the benchmark results against all the supported devices and browsers to determine whether the results are consistent across the supported browsers or not, or where are the areas in which we need to do more optimization in terms of the front-end code of the application. We did a very similar test in one of the projects that we executed. The project was Oyala. Oyala is a very popular commercial video publishing and monetizing platform, and they have a player called as Oyala Player. We built a test for them which was called as Oyala Player Load Time Benchmarking Test, and the intention of the test was to optimize the time it takes for the player to actually start playing the video once the play button of the video is pressed. We created a benchmark test for them for Oyala Player, and not only we executed the test on different browser versions and Flash versions, but we also executed the test under different browser usage scenarios. For instance, a cold scenario in which we did not allow the browser to cache any of the player components, and to do that we executed all the iterations, each of the iterations of the test in a different instance of the browser. A warm scenario in which we allow the browser to store and use the local cache of the browser and not the session cache of the browser, in which we executed each of the iterations in a different tab on the same browser's instance. And a hot scenario in which we allowed the browser to use both local cache as well as session cache of the Flash components. And in this case, we reuse the same instance and tab to execute each of the iterations for the test. With the kind of reports that we were able to draw from these tests, we were able to provide enough material for the developers so that over a period of couple of builds, they were able to optimize the Flash code and the time that the player takes to actually start playing the video once the play button is pressed. And the overall experience was enhanced. A second approach of implementing UI profiling would be a hybrid approach in which we execute the UI profiling test on top of our load tests, or we can collectively analyze the results of load test aside with the results that we get from UI profiling, in-browser user experience profiling. The activity rendered time in browser can be the average, the difference of average of in-browser response time and the average of HTTP response time that we got from our load tests. We executed one of a similar test using a load test tool JMeter, and we executed in-browser profiling test using our framework on top of that test while the test was executing. And in this case, the subject was imdb.com. We again benchmark two different set of activities, homepage load time as well as search result display time. And in both the cases, we did the execution for about 500 different samples. You can clearly see that the first graph for JMeter and the second graph is for in-browser profiling. The blue line is the response times for each of the iterations, and red line is the average of all these response times over 500 different samples. So the overall application render time would be the difference of the response time that we get inside the browser versus the response time that we get from our load tests. With this, I'd like to conclude the webinar. What we have seen is that benchmarking applications HTTP performance does not incorporate the overall in-browser user experience, because this does not include the render time that the browser takes to display the application properly. Whereas from an end user's perspective, he would always see the overall response time, which would be a collection of the HTTP performance and the in-browser user experience, in-browser application response time. Web application interface, that is the HTML code, the JavaScript, all the code that is executed at the client side, and the configuration that the user uses to access the application, they together play an important role in deciding the overall user experience of that user. As we have demonstrated, open source test automation solutions can be used to do in-browser user experience profiling, and in combination with load tests or by doing systematic benchmarking, we can optimize the overall user experience of the application UI. The same approach can be used to do thick and thin, to do user experience profiling of thick and thin desktop applications as well. We are now open for questions, so over to Siddharth.
Thank you, Raman. I believe this was a very informative and intriguing session, to say the least. It did generate some interest based on the number of questions that we have received. We'll now start off with the Q&A phase and try to answer as many questions as possible. If any of your questions do not come up here, please do not worry, as we'll definitely respond to them later via email. So let's start off with the first question here. Raman, why don't you answer this one? So how is this different from using Wiselo or Google PageSpeed?
Okay, that is a very interesting question. So Wiselo, which is a tool that is provided by Yahoo, and PageSpeed is a tool which is provided by, I think, Google. These two tools do a very similar thing. They help developers in determining the response times, the overall load times of the application pages. But what they lack is in the context of the user experience that they provide. In the sense, when these tools would tell you how much time that the page takes to properly load, but when we're talking in terms of the activities that the user is performing inside the browser, these tools do not provide that context. But when we are doing these kind of profiling using an automation tool, we can get the results in context of the real activities that the user would perform. And the response time would be, the performance results would be of those activities rather than the page load.
Thank you, Raman. Okay, let's give you some break, and I'll pass on the next question to Prashant. Folks, Prashant, let me just introduce. Prashant is our automation. He leads some initiatives for us on automation and performance at Q Infotech, and he works closely with Raman. Prashant, the question for you is, are there any commercial tools that offer a similar solution for application user experience profiling as of today? And if so, how does your framework compare to it in terms of feature richness?
Thank you, Siddharth. Well, there are tools like a load runner, GUI profiler, YSlow, and well, sometimes even the developer tools like Firebug can be used to do the profiling, but all they do is they capture the response time in bits and pieces. None of these tools take into account the impact of load on the page rendering, or either they are not able to filter the results focus on the individual page objects or elements. Say, for example, if you are looking to verify if a particular page element is displayed in a certain amount of time, the whole capability is missing from any singular tool. Our framework is not only open source, unlike the other tools. It does leverage the existing automation scripts and load test. And if in case these scripts are missing, our automation framework can be used to scale up for load test and automation tests. It also allows us the flexibility to monitor segregated individual components on any page, and it also allows us to generate customized reports. And along with all this, it's also CI ready. So you can plug it in and plug it in our automation framework in your CI tool and have scheduled benchmarking tests executed automatically and along with each build as it goes.
Thank you, Prashant. So the next question, if user's configuration is slow, it is obvious that the application performance will be slow as well. Why do we need to then benchmark application performance on slower devices and systems? Kunal?
Yeah, Siddharth, thanks. I would like to take this one. So we need to provide a benchmark to the client, to set the expectations that if an application is rich, it needs a minimum set of resources. And in case the user machine or device does not have those resources, the user experience, it would degrade by a certain percentage. Also, there is a valid scenario for smart devices which do not have the similar resources as desktops or laptops, but their usage has increased by many-fold in past couple of years. So it makes it absolutely necessary to measure and improve the performance on these low configuration devices in order to retain the customership and to provide them the flexibility to be using these applications on the smart devices. Hope that answers the question.
Thank you, Kunal. For the next question, let's go over to Raman again. Given an increasing amount of mobile computing, what can the developers and testers do, and how can they collaborate better to ensure user experience is not compromised and solve this problem as well?
Right. This is one of the approaches that I mentioned in the webinar also. The very best way of handling this to do it in a collaborative fashion with the developers is that we make user experience profiling a part of our standard test execution cycle. So with every new build, we have the user experience profiling tests in place, and we execute them and publish the report of the user activity responses build by build. These reports and records can then in turn be used by developers to determine the optimization level that they have to do across their application UI. And I think that is the best approach that can be followed in this case.
Thank you, Raman. All right, that's it with the questions. So thank you so much for joining us in this web event and spending the last few minutes with us. I would also like to thank Kunal and Ramandeep for sharing their thoughts and insights with us. We hope you found it useful and informative. You will soon receive a short survey about today's event, and we would really appreciate if you could please take out a few minutes to provide your valuable feedback. You may log off at this time. Have a nice day. Thank you.